Hi everyone, here are your notes for section 4.2, which is getting us into solving systems with three variables. So by the end of this lesson, you should hopefully be masters of solving systems with three variables. Now, if you remember, you had systems with two variables from section 4.1. So whenever you have two unknown variables that you need to solve for, so x and comma y, you need to have two equations, right? Because you need an x and a y in those two equations. And then hopefully you are good to go with either using the substitution method or using elimination to solve for those x and y's. Just quick refresher also, remember if you end up with something like 0 equals 0, we write out our answer as the set of ordered pairs x comma y such that, and then you write your equation in standard form following that such that bar. That's our such that bar. And if we end up with an answer like 0 is equal to 10, which is false, then our answers are no solution. Okay, so make sure you have those in the back of your head. So now, if we have three variables that we need to solve for, so now what we're going to do is we're going to be adding an x, a y, and a z to our answer, which means we're going to have a tripled order. Not an ordered pair, we're going to have a tripled order as our final answer. So a tripled order is x, comma, y, comma, z. So if we're graphing that, it's the three-dimensional world. So we have our x and our y axis. Now envision a three-dimensional axis shooting straight out at you. That would be axis z. So that's what makes things three-dimensional, is when you add in that third variable of z. X and y is just two-dimensional. Adding the z gives us the three-dimensional, where it's shooting out at you. Okay, so here we go. Let's do it. So solve the following systems. Now, since we have three different variables to solve for, we need three different equations to solve for those three variables. So my first equation is x plus y plus z equals 2. My second equation is x minus y plus 2z equals 2. And my third equation is negative x plus 2y minus z equals 1. So now, just so we can all talk about the same equation, I'm going to label them as line 1, line 2, line 3. Just so you can know what I'm referencing, I can just say, let's talk about equation 1. Okay, so now we need to make the decision on which variable we want to eliminate first. So I'm going to take a look at these. If I combined line 1 with line 2, does everybody see how the y's, the y's would cancel out? If I added my x's, I would get 2x. If I added my z's, I would get 3z. If I added my constants, I would get 4. But my y's would go away. If I were to add equation 2 and 3, does everybody see how my x's would eliminate? My y's wouldn't, my z's wouldn't, and my constants wouldn't. So I've got some options. I can either pick the y to go first or the x to go first. There is no right or wrong answer. I'm going to go with the y's just because that's line 1 and line 2. So because they eliminate right away, let's go ahead and combine them together by adding. So this x plus this x makes 2x's. My y's go away. And then 1z plus 2z's makes 3z's. And then everything on the right adds up to 4. So now I have an equation with just two variables. What are those two variables? Well, I have an x and I have a z. So now what I need to do is I need to bring the equation that I did not touch yet, which was equation 3, and I need to bring that into play. I need to get rid of the y, which means I need to combine it either with 3 with 1 or 3 with 2. There is no right or wrong answer to that question. I personally would pick to combine 2 and 3 because if you look at your y's, I have a negative and a positive. So I don't have to worry about getting them to be opposite in sign. I just need to worry about the coefficients to be the same. If I were to combine 3 with 1, that would be okay. It's just now I have a positive and a positive, so I would need to make sure I multiply one of those lines by a negative. So let's go ahead and combine 2 and 3. So before I can go ahead and start adding, I have a positive 2y here, which means I need this to become a negative 2y. So I'm going to now multiply my second line by a positive 2. I'm going to rewrite it below here. So multiplying 2 to the x gets me 2x. Multiplying 2 to the y gets me negative 2y. Multiplying 2 to 2z gets me 4z. And multiplying 2 to 2 gets me 4. So now when I combine those, I get negative x plus 2x, which is 1x. My y's go away, which is what I wanted, because notice I have no y's up here. My z's go to 3z, and 1 plus 4 gets me to 5. So now I have a linear system with 2 unknown variables. They are the same unknown variables. If they were not the same, then I would know that I didn't do something right, and I need to go back and eliminate the one that I needed to eliminate in the first place. So now we can solve this just like we did back in 4-1. I'm going to eliminate the z's because I have the same coefficient. They both have a 3 in front. So all I really need to do is multiply one of them by a negative 1. So my new system, top doesn't change, 2x plus 3z equals 4. My bottom now becomes negative x minus 3z equals negative 5. Adding straight up and down gets me x is equal to negative 1. Oh, that was nice. Now let's get another variable. Well, I had 1. If I go up to one of these originals, I could get a second, which would be z. In this case, I'm going to go to the one that has the least amount of numbers, which is this guy right here. Okay, so we just said our x was negative 1 plus 3z is equal to 5. Adding 1 over gets us 3z equals 6. Dividing by 3 gets us z is equal to 2. All right, now I've got 2 out of the 3 that we need. I have an x, I have a z. Now we need to solve for a y. So now I'm going to go back to where I had all 3 of them, which was up here in the originals. And I'm going to pick either line 1, line 2, or line 3 to plug it into. Me personally, line 1's looking the simplest. There's no negatives in there, and there's all small numbers. So I'm going to plug in negative 1 for x. Y stays a y. I'm going to plug in 2 for z and equal that to 2. Okay, so we're plugging in negative 1 here and 2 here. And then solving. So now we get y plus 1 equals 2. Y is equal to 1. So there are your 3 ordered pairs. How do we write it? Well, we write it as a tripled order. So negative 1, or not 3 ordered pairs, 3 coordinates. So negative 1, then your y comes next. Always put it in alphabetical order. And then your z. Make it fancy. Technically, you can go and check all of that and make sure it works. If I plug those into line 1, negative 1 plus 1 is 0. 0 plus 2 is 2. Check. Line 2. Negative 1 minus 1 is negative 2. Negative 2 plus 2 times 2 is 4 is 2. Check. Number 3. Negative of negative 1 is 1. 2 times 1 is 2. So that gets me 3. 3 minus 2 is 1. Check. I know I did all of them right. Okay. See if you can do one on your own. Did you get negative 1, 1, 2? Hopefully you did. Again, my solution might be different than your solution when I go to solve this, depending on what you eliminated first. So it's kind of hard to see where you went wrong or compare it to me. You could have eliminated your x's right away, right here. Or you could have eliminated your x's right away, right here. So I probably would have done x's since they eliminate in all 3 ways. Your y's did eliminate, or your z's could have eliminated. So if you would have went with x, we could have done line 2 and 3, which would have gotten you y plus z equals 3. Then you could have done 1 and 3, which would have gotten you to 3y equals 3, because notice your z's cancel out there. So then you get y equals 1 right away. Plug that into here. 1 plus z equals 3. So z is equal to 2. And then go back into one of the original ones. I'm going to go in the first one. X plus y, so plus 1, plus 2, which is our z, is equal to 2. X plus 3 equals 2. X equals negative 1. So that's where all your numbers would come from. So probably the easiest one would have been to eliminate x's first, though it would not have been wrong to do it otherwise. All right, let's do another one that's not quite as nice. X plus 3y minus 6z equals 7. 2x minus y plus z equals 1. X plus 2y plus 2z is equal to negative 1. All right, so let's look at this. I've got line 1, 2, and then 3. Nothing cancels out right away, so that's going to not work. But look at these x's. They both have the same coefficient, so that might be easiest to get those to eliminate. So I'm going to make one of those a negative. So I'm going to keep line 1 as it is. X plus 3y minus 6z equals 7. Now I'm going to take the negative of everything in line 3. So negative x minus 2y minus 2z equals positive 1. Because now when I add straight up and down, my x's will cancel. So now I have 1y minus 8z is equal to 8. All right, so now I have an equation with no x. So now I need to bring equation 2 into play and eliminate its x with either line 1 or line 3. I'm personally going to use line 3 just because those are smaller numbers than line 1. But again, no correct right or wrong path. There's multiple paths. All right, so I'm going to bring down my line 2 here. So 2x minus y plus z equals 1. I'm going to multiply everything in line 2 to a negative 2, or line 3 by negative 2. So then I would get negative 2x minus 4y minus 2z is equal to positive 2. Adding straight up and down gets us negative 5y minus 3z equals 3. So now I have two equations. Each do not have an x involved. So now I'm going to bring this guy up here. Negative 5y minus 3z is equal to 3. Nothing eliminates, so we're going to have to do some manipulation. I'm going to eliminate my y's first. I'm going to multiply this top line by a positive 5. So now my new system is 5y minus 40z is equal to 40. Second line doesn't change. Negative 5y minus 3z equals 3. Adding gets us negative 43. Z is equal to 43. All of that work to get negative 1. Now I'm going to go back up to either this line or this line with my negative 1. I'm going to go to the first one. Y minus 8 times negative 1 equals 8. Y plus 8 equals 8. So y ends up being 0. Now I've got 2 out of the 3. So where do we go to get the third? Back to the originals. So just pick which one you like. I guess I'll go with the top one just because it's on the top and that gives me more space. We're solving for x. We have x plus 3. We just said y is 0. Minus 6. We said z is negative 1 equals 7. So that gets me x plus 6 equals 7, which gets me x is equal to 1. So my final answer as a tripled order is 1, 0, negative 1. I know, a lot of work, right? But it's fun work. Go slowly so you don't make mistakes. Always check your work to make sure that you did it correctly. Okay, moving on to the next one. Here we go. 4x plus y plus z equals 2. We have an x plus 7y minus 3z equals negative 14. And 2x minus 3y plus 2z is equal to 3. Take a moment to write that down. Pause if you need to, but I'll go ahead and start working. Nothing looks like it's eliminating right away. So now we can make the choice of what we want to eliminate. I'm going to go with x's just because they're first, and 4 and 2 and 1 are pretty nice numbers to work with. So if I wanted to try to get my top two lines to eliminate, I would need to multiply my second line by -4. So my first stays 4x plus 8y plus z equals 2. My second becomes -4x minus 28y plus 12z is equal to 14 times 4 is 56, and the negatives cancel. Adding up and down gets me -20y plus 13z is equal to 58. Okay, so now I just used the first two lines. Now I got to bring the third line into the party. So that has a 2. It probably would be easiest to either multiply line 2 by a -2, or I could multiply line 3 by -2 and add it to the 4x. I'm going to probably work with the smaller numbers. I'm going to now multiply my second line by -2. So that gets me -2x minus 14y plus 6z equals 28. Line 3 stays 2x minus 3y plus 2z equals 3. Adding up and down, -17y plus 8z equals 31. Bring these guys together. Let's introduce them. -17y plus 8z equals 31. Oh boy, we got some big numbers there. What are we going to do? Well, we got to figure out what to multiply them with. So 20 and 17, looks like we're going to have to multiply the top one by a positive 17 and the bottom one by a 20. One of those needs to be a negative so that I get opposite signs. Oh, thank goodness I have a calculator. 17 times 20 is 340, so -340y plus 17 times 13 is 221z. 58 times 17 is 986. Down below, we get positive 340y. 20 times 8 is 160, negative 160z. 31 times 20 is 620, negative. Adding straight up and down, 221 minus 160 is 61z. 986 minus 620 is 366. Divided by 61 gets us 6. All that work for 6, huh? All right, so now where do we go from there? Well, we have one variable, so let's go back to where I had two variable equations, there and there. Which one looks nicer? I don't know. They both look pretty rough to me. I'm going to go into the second one. So let's do a -17y plus 8 times 6 equals 31. 8 times 6 is 48. So -17y plus 48 is equal to 31. 31 minus 48 is -17. So -17y equals -17. So y is equal to 1. All that work for a 1. So now where do we go? Go back to one of the original ones. I'm going to go to the top one. I like even numbers. Those are nice. Except for 1. That was not even. So we're solving for x. So 4x plus, we just said 1 was y. So 8 times 1. Plus z is 6 equals 2. So 4x plus 8 plus 6. So 8 plus 6 is 14 equals 2. Subtracting 14, 4x equals -12. And then we have it at -3. All right. So my final answer is -3. My y is 1. My z is 6. Set notation. Check your work. All right, so now you may end up seeing problems that have gaps in them. Or you have something like this. 6x minus 12y equals -5. 8y, and I purposely left a gap there, plus z equals 0, and 9x minus z equals 12. So notice that I have an x and a y here. I have an x and a z here. I have an 8 and a z here. So how do I even do any of that? So 6x minus 12y equals negative 5. 8y plus z equals 0. 9x minus z equals 12. Well, we can't eliminate an x. Well, I guess we could try to eliminate an x and see what happens. Let's do z's. Does everybody see how your z's go away really nicely right here? Let's do that. Let's combine line 2 and line 3, which would get you 8. Let's do x first. 9x plus 8y. My z's go away, and 0 plus 12 is 12. Ooh, that looks nicer. Now I have just an x and a y included together, which did not come to the party. The top equation. Notice that already has an x and a y. Ooh, that's nice. 6x minus 12y is equal to negative 5. This looks like familiar territory. What can I turn 8 and 12 both into? 24, multiply by a 3, multiply by 2. New equations, 27x plus 24y equals 36. 12x minus 24y is equal to negative 10. 27 plus 12 is 39x equals 36 minus 10 is 26. 26 divided by 39 gets us a fraction of 2/3. That's our answer there. Now let's go back into one of our two. So either this one or this one. I'm going to go into the top one, I guess. So we just said x was 2/3 plus 8y equals 12. 9 times 2 is 18. 18 divided by 3 is 6 plus 8y equals 12. Subtracting 6 gets us 8y equals 6. So y is equal to 6 over 8, which is taking out 2 3/4. Now go back to the original. We have an x, we have a y, so we need a z. So I need one of the equations with a z. I guess I'll go with that one. 9 times our x, which is 2/3 minus z equals 12. 9 times 2 is 18, divided by 3 is 6, minus z equals 12. Subtracting 6 gets us 6. So z is equal to negative 6. So our final answer is our x, which was 3/4, my y, or no, did I just do that wrong? X was 2/3, sorry. 2/3. My y is 3/4, and my z is negative 6. Fractions are okay. They are our friends. All right. See if you can do one on your own. Did you get 4, negative 2, 1? Hopefully you did. If not, ask tomorrow. We can go over it in class. All right, so now let's finish with some special systems. So what happens when we get things canceling out from each other? So here we have 2x minus 4y plus 6z equals 5, and negative x plus 3y minus 2z equals negative 1. X minus 2y plus 3z equals positive 1. Right away, I see x is going away. That makes me happy. So let's combine those two together to get y plus z equals 0. If I wanted to eliminate the x's, let's say here, I would need to multiply my second line by 2. So that gets me, I'm going to rewrite 2x minus 4y plus 6z equals 5. That's just rewriting the first line. My second line now becomes negative 2x plus 6y minus 4z equals negative 2. So when I combine those, we get 2y plus 2z is equal to 3. Bring these guys together. 2y plus 2z is equal to 3. And then solving that out, multiply your top by negative 2. So negative 2y minus 2z equals 0. 2y plus 2z equals 3. Uh-oh, now what's happening? We get 0 is equal to 3. Is that true? No, that's false. So my final answer is no solution. You may get to that no solution quicker and get things canceling out sooner. That may be possible depending on the type of equations that you have. But at any point in time, if you get all your variables cancel out on the left-hand side, you're going to end up with either no solution or infinitely many. All right, here we go. Oh, this one looks like fun. We got some fractions. 2x minus 3y plus 4z equals 8. Negative x plus 3/2 y minus 2z equals negative 4. And 6x minus 9y plus 12z equals 24. First thing I would do is get rid of that fraction. I'll multiply everything in line 2 by 2 to get negative 2x plus 3y minus 4z equals negative 8. Now look at that compared to the first one. 2x minus 3y plus 4z equals positive 8. What's going to happen? 0 on the left, 0 on the right. So that means we have infinitely many solutions. That means all three of these lines probably are the same exact equation. So how do we write out infinitely many solutions in advanced algebra? Well, now we have the set of the tripled order of x comma y comma z such that, and now I got to rewrite standard form. So go with the one that has no fractions and the smallest numbers. So in this case, 2x minus 3y plus 4z equals 8. Close it. Answer. Okay, so that's where we get the infinitely many solutions. So it's the set of all tripled orders such that they fall on the line 2x minus 3y plus 4z equals 8. All right, that concludes your notes. Move on to your next task. Bye.